Okay, so far we have been talking about how to control a lamp with switches. What I mean by a switch, I mean a device, a mechanical device like this one, that you probably have one at home, that will control a lamp. And by turning on and closing and opening this switch, we represent by 1 or true and or 0 or false the state of that switch. But as you can see, this switch is really big, and we will need a lot of switches to make some real meaning of what we want to do. So uh, technology evolves, and we invent new things. So um, we wanted to create some kind of the same logic, like AND, OR, NOT, and XOR. And as you can see here, all those gates, they are interconnected together to form some kind of a logic, and we will talk about that later on. That will be making some cool stuff. And we want to do all those things, all those switches, to put them in a small microprocessor unit or microchip, and we want them to do something that we need. But we cannot use a mechanical switch, as you can guess, like this. So we had to really invent something small, but it didn't just happen overnight. So first, they created something what we call a transistor, which is looking really pretty much like a bulb, but this is a switch actually. This is you can use this switch or this switch. They are the same thing. The only difference that this one you have to push on it with your finger, but this one you have to apply some small microvolts here or millivolts to close the switch here. So if you want this, you apply a small amount of electricity here, and then it will close the circuit here, and this will close just like this switch, the regular switch 1 or 0. And it's very important to understand that uh, this transistor, this old-fashioned transistor, which was used in the beginning of I don't know which year they were using this kind of transistor, but it's really an old system, and that's how it works. So you have electricity coming here and a small electricity coming here from the signal, and whenever there is a signal, this the anode and cathode, they will be connected together, so it's like closing the switch. After a few years, they created some kind of machines that uses this kind of switch to make some logic operations and or XOR and all the good stuff here. And that was a little bit problematic because those bulbs, they used to burn out quickly because of the heat. They produce a lot of heat, and when you put a lot of bulbs together or transistors, this kind of transistor, it's called a vacuum transistor, by the way. So when you put a lot of vacuum transistors together, they will work for some time, and then poof, if one gets burned out, a lot of logic is going to be broken, and then the computer is not going to work. So they invented some new stuff. So we'll just go to the next. Here there came the transistor. The transistor is this is the transistor that we use today. It's much smaller than this one, than the bulb one. You don't need a vacuum or anything. It's made of semiconductors, germanium, silicium, and some other stuff. So they create a microchip, really a electronic based component that you can use the same way with the same logic. So you have the base where you can put some tiny microvolts or millivolts that can control the collector and the emitter, just like this this transistor, but much tinier and less uh, producing less heat, which makes it very robust and very efficient way to make a switch. So uh, creating a transistor is about the size of, let's say, your fingernail, or your pinky fingernail. It's really tiny, but that was not enough to put. If we want to make it really tiny, the smaller the transistor is, the more switches we can have, the more power we can get from computers. So, of course, when we talk about a microchip, that's what we need, what we mean by microchip. So now we want to put a lot of switches into the microchip. So imagine you want to put a lot of switches in a micro chip like this one. So with time, they went on and they created smaller and smaller and smaller transistors. Nowadays, that was one transistor in 1950, and that was just one transistor. It's a microscopic one. In 1960s, we created the TTL quad gate transistors, and the microchip had up to 16 transistors in it. In the 70s, we started making 4,800 transistors. In the 80s, 275,000 transistors. In the 90s, 3 million transistors in a microchip. In the 2000s, half billion transistor. And in 2010s, we we are producing 8 billion transistor. So when you are probably in your computer right now, you have more than a billion transistor in your microchip. This is really, imagine it's like you have 8 billion switches like this in your microchip, and that will allow us to do some crazy mathematical formulas, which is our next video that we will talk about it, which is the binary code. I hope this gives you a little bit some insight of what a computer is inside. It's nothing but just a bunch of switches that are ordered in a specific way, just like this one, to create some logic gates, and or not, X or, and that's all.